Hello guys, how are you? Hope all of you are doing well. So in this video, my motive is to teach you how to deploy your Node.js containers securely in a serverless environment. So before I start my video, I just wanted to explain you the benefits of using the containers in Lambda. So we'd like to use the containers because it has more size limit compared to traditional zip. Here you are getting like almost about 10 gigs I think. On the other hand, the zip is very small, which is confined to megabyte I think, or maybe few gigabytes. So this is one of the main advantages I would say. Besides that, there are also some advantages like the cold start time, because we all know that the cold start time for a zip file is much more competitively to the cold start time of a container. Because what happens in the process is, when you upload a normal zip file, the zip file needs to be fetched from the S3, and using that code file, it needs to spin up a container, and then that container serves the request. So if you just remove the step of fetching the S3 code and making a new container. So this making a new container from the code is like a expensive process, because you are making images, containers and all the stuffs in the go. So in that case, if you directly supply an image, then AWS can directly spun up containers very easily instead of going through the expensive process. So I think it is much more feasible for reducing cold start time. Besides that, if you use containers, then it is very easy to maintain a deployment chain where you can keep version your images and keep all the things like in an organized way. So it's also a benefit for me actually. And normally serverless is useful because if you can deploy containers in serverless, then the fact is that it is very cheap. So you can upload any of your test projects or dummy project for your testing. So this is also a very big advantage, like a cost advantage to me. So if you want to deploy a container to the serverless, this process is quite different from if you wanted to deploy it in a zip method. So this article was written to explain all of that. I will definitely give this article link to your description in my description so that you can check, but I will just highlight the most important part so that you don't miss that. Okay, so the first thing that is most important is the handler is inside the container. So whenever you use the zip method, the handler is directly in the IAC or the infrastructure code file you are using. But in the case of container, the handler will come inside the code actually, and also inside the container. So here we can see that there in the CMD we are not passing any command, rather we are indicating or referencing a handler, which handler is present in our code. So here index.handler represent the handler function of index.js. So you need to keep this thing in mind because it is very important. And on the other hand, the second thing which is very important is your node runtime is not alone sufficient for running the serverless container, because it will need support of an extra binary which is known as AWS RIC, which is runtime interface client. We can read much more about runtime interface client from here. So it will help you to actually function properly with the Lambda environment and with the AWS. So you must have this binary. So we can see that we are installing lots of build dependencies just to install the Lambda RIC properly. So these installations are very much necessary for installing AWS Lambda RIC properly, and you must install it, because without it your things will go wrong and it will not work properly. And by the way, you should also be very careful in maintaining this handler and the referring this handler in the CMD. So this was some precautions you need to be careful, otherwise you can read the full article as you want. So I will go to the next step, and which is talking about security, because as you are deploying the container in Lambda, so your clients will be directly communicating with your container. So the first layer security is your container itself. So that means the container you will be releasing, the clients will be directly communicating with the container. Normally when you deploy these containers using Kubernetes or something else, you get additional security layers before they reach your containers, like the OS security, network security, and all those stuffs. But here in serverless, as you're not getting into a complex system design and directly deploying your AWS to a AWS specific VPC instead of the VPC we own to give network capabilities. So we are directly exposing our container publicly. So it is very much necessary that your container is secure in this case. And another performance tips which I will definitely follow, that if your image size is smaller, then it will load quickly comparatively to if your image size is much larger. So in that case, you have to reduce your image size so that from larger image it comes to smaller image, so that it gives you faster load time during the cold start period. So if I check the Docker image of Node latest, so this is the official Node latest image present in Docker Hub, we can see that its size is 1.1 gigabyte and it has lots of red, yellow vulnerabilities. So we cannot choose this image anyway because this is like horrible, right? 1.1 gigabyte and all those stuffs. We cannot choose this for our deployment, which will be a very bad decision. So what can we do is we can choose a good base image for our supply chain so that our whole ecosystem remains secure. So in that case, I am using a special kind of image called Chainguard node image, which has just a single layer and which size is only 121.24 megabyte. So can you just imagine that its size is much lower comparatively to 1 gigabyte. So this is a very good engineering decision if you choose this image because it's completely free, and this is a special kind of company, and I will discuss more about this company in the upcoming conversation. So you can also see that it's fully secure with one layer. So now the question comes that how is it reduce its size so significantly comparatively to the main official repo. On the other hand, how it is also offering a so secure image. So let's deep dive into it. So the thing we have to notice here is that these Chainguard images are like powered by Olfi, which is a suite of distroless images that provides support for both muscle and glib. So that what makes their image difference is that they are distroless in the sense that they are minimal to the point of not even having a package manager such as apt or apk. So they are not even having a package manager, so you cannot run apt install, apk install, something like that. And at Chainguard, we believe minimizing dependencies such as much possible, which simplifies auditing, updating, refreshing, transferring, and so on. So here you can see that lots of benefits and how they are actually reducing their image size by using something called Olfi, which is their own made Linux distro, which is very minimal, that it has very less dependencies and which includes only necessary dependencies. That's why their image size is so low. So if I just tell you that how you can learn more about their images, so there is a website called Chainguard Academy. So you can learn more about all kind of images they offer from their website. So here you need to keep two things in mind, that the tag history. So there is a huge collection of image here, but you will only get access because it's a private dedicated repository. So you need to take additional steps to, or maybe pay to them to get access to this kind of images. On the other hand, this is the public registry where these two images are free for you, and these two images also have some subtle difference that I will be explaining in coming moments. So these two images are for public use, so we will use these public images in this tutorial. So if you go to details, then we can see that the latest dev and latest have some differences, and the differences lies in the last two lines. So here it has a APK, yes, it doesn't have a APK. So this is the only difference here. So what this difference is making is that in your Docker file you cannot run anything like apt install, and other than that everything stays same. And the other thing I wanted to show you is about the compatibility. So here, if you see the compatibility, you will see that the image specifies default non-root user and a working directory of /app. So it is also a very plus point, because normally in Docker containers, it is every command is run as a root and the root is the only user. So by chance, if a hacker gets access to your container, he is already a root user and he can do whatever he want. But on the other hand, here, if a hacker gets chance, which is very less because their image is very much secure, so even if any hacker gets chance, then they are not will be logged in as a root user but a normal node user. So in that case, I think it is very useful, because this non-root user feature is very much something Podman also offers, and this is a very useful feature, I think, according to me, because if you are not logged in as a root user, then the attack surface, even if your container gets hacked, the hacker can't do much stuffs. So this is also a beneficial feature, I think. So you need to keep in mind that you cannot run any command, because now you are not a root user, you are just a node user. So let's start our development process, because that was a long talking, but that talking was very much necessary for all of you to understand the whole concept, because lots of tutorial are like existing on the YouTube which are not explaining things properly. So my motive was to explain all the things in depth. So let's start the deployment procedure. So for starting the development procedure, you can see that this is a bun project. So at first we need to convert this bun to a node. So for that you need to do two steps actually. Run this build command and run this post build command. This post build and build command both are very important to compile your bun project successfully to a server.js or to a .js file. So don't miss these two steps, and I will include all the possible links in the description, even the repo link, so that you can follow. So then what you have to do is just run the command bun run build, and when you will run the command, it will generate a server.js file for you. It will look something like this. So our build is done. So let's go to the next process. Now we will write our Docker file. So we are choosing /app because we have already seen that this node user has access to /app. Okay, and we are making the Docker file based on this example. Where is the Docker file? Yeah, based on this example. So let's get back to the Docker file. So here I am using a build image at first, and then what I am doing is actually, and you can see that here I am using apt, and apt is not available in this image, so I cannot use it as a build image. So at first you need to install all of this, and then install the lambda RIC, which is the most important step I have already discussed. You have to install the npx and all the stuff, so you can check the whole file. Okay, and then here we can see the interesting part, that from Chainguard node latest, here I am using my latest uh, secure base image, which is the Chainguard image, and then I am continuing the rest of the steps. So you can further investigate more this Docker file, as this will be included. So here the important thing that you have to understand is the server.handler that I am included, because my file name is server.js, so I'm the server and the handler. And here I want to notify one thing is, like, if I go to my source and server.ts, my handler is not exactly same as the AWS one. So if I go to the AWS and see their handler is very basic. But as I am launching an Express application, as you can see, I'm using Express here. So in that case, I am also using a library called Code Genie. So all the code will be given to you. So this is actually converting and making a serverless handler for me. So by using this Code Genie, I am actually returning or making the handler and returning the serverless express instance. So this is like using a library to modify the handler in a specific modern way or something like that, so that it can understand what kind of request is coming to my API and give it to my express application in that way, so that the single lambda function can handle all the API routes. So this was something important to remember, that this handler function is not an ordinary handler function. So now let's go to deployment. So now our Docker file is ready, our server.ts file is ready, everything is ready. So now we have to use something called serverless. So here I am using the serverless framework. So you can see that the file is so minimal. Here what I am doing is just the basic syntax. If you know the serverless framework, it is very easy. So you can learn more about from their documentation. So the here you need to be cautious in two important things: the environment files. So if I just pull it a little bit here, just so that I don't want you to see my environment files. So in my env.yaml, you can actually see that I have two things: the Mongo URL and the this is my environment variables I'm supplying, and these are my the events.yaml I am supplying. So these are my API routes. So you can say that generating this manually or writing this manually for big APIs is a very big or tiring task. Yes, I know that. So I have automated this stuff in my server.ts file. So I am using here something like express list endpoints, and then I am generating populate API events, which is generating the events.yaml file already for me. So if I just run and uh, gen hyphen routes, which will generate the routes for me, and you can see that it has generated all routes, events.yaml, and all the files and all the routes of my express application was automatically written for me. And I am using this env.yaml and events.yaml to refer in the serverless YAML file. So all the environment from this env YAML file will come into this environment place, and all the events for this single to do app function will come under this events. So I hope this is very much clear to you, and if it's not clear, then you can absolutely refer to the serverless documentation, because it is this video is not about teaching serverless framework. So I think you have understood what I'm trying to say here right now, and how I have automatically generated the events.yaml file. So now everything is almost ready, so we just need to deploy our application and test it. So for deploying, I will run deploy command and wait for some time, and looks like it's building our image for us. That's good. Officially it's good. So it may take some time, so we can wait actually. And we can see that it's already have been deployed. So very nice, it has already deployed our stuffs. So time to see our resources. So in our cloud resources, if we reload, we can see that we have something called to do API production, and it has created a lot of resources. So we will just go through these resources very quickly and finally test our application. So this is the to do app log, which will help us to see all our loggings of our serverless function. So if I go here and wait for some time, uh, okay. So if I go to the log streams, then you can see that I have some previous log streams as I was testing earlier, but currently I do not have any log stream because I haven't invoked the function yet. And more than that, I have my lambda function, and then I have my lambda role, serverless deployment bucket, and all those stuffs to store the settings and all those stuffs. And my image here, one thing I have forgot is that here it will take the image path, the Docker file path here, and automatically build the image for you and then upload to ECR. Here you can see ECR. So if I just check my ECR here, So if I just type here ECR and go to my elastic container registry, so I can see my serverless to do app here and the to do API here. Okay, so this is my image that I have been uploaded here. So I wanted to show you that the image is getting successfully uploaded to the ECR. And the more resources, if I wanted to check, is we can check the API gateway also. So this is our API gateway, and if I check the routes, all the routes defined in our events were successfully mapped here, we can see. So everything was quite smooth and automatic. So now time to test our application. For testing our API or Express API, I am using Insomnia. You can use Postman or whatever you want. And we are very end of our video. So just let's invoke it and wait for some time, and you can see that how fast the thing has reloaded, just because we are directly invoking the containers instead of following the normal lambda procedure. So this is the hello from lambda, so our application is working perfect. What I will do is make a new user, brand new user, so example 8, and the password will be password 8, and sign in and wait for some time, and the user is already signed in. We will log in as that user, make it example 8, and let's see, our user is logged in. We will try to get the session. Yes, we already have a logged in session. We will open the to do, add a to do, and say Chainguard is awesome, or like add a real task like make a video, something like that, and add this. And if you come to user to dos and see, we can see that we have a pending task called make a video. So we need to just copy this ID for our sake and update the complete status in the update function. So what we will do is just replace it with normal v and send it. So it is saying to do was updated. We will see check. Our computer has converted to true. Our serverless API is working perfectly. And the final thing I have to check is the remove to do. So we will remove the same ID that we have updated, saying to do removed. We will say user to dos, and then actually I will run and see our to do get go has already get deleted. So as I've already deployed the application before recording this video, that's why this deployment was very fast, and I also had my URL that I have stored in the production environment. So if I show you, so in my production environment I have already set up the AWS API, which is www.execute API center on Amazon AWS.com. So it was already using this URL and this version, and this base version includes my uh, localhost, but I was running the production environment as you see, which is this URL. And if we check in our API, then we can see that this URL is exactly same. This API URL Carlton Central 1 is equivalent to the URL I was sending request to. So if I go to the production again, so you can see that this URL is exactly the same. So yes, so this was the concept of the whole video. So I tried to make this video unique and informative as much as possible by keeping this video short, so that you can understand how you should actually build your image properly and deploy your applications and never think again about it. So I hope you would like this video and share it to your friends. Thanks for watching, and I will see you in another video.